Soil is a part of our everyday lives, but how much do you know about what's under your feet? Let's start by asking, how does soil become soil? There are 5 soil-forming factors, or components that play into the formation of a soil: parent material, topography, climate, organisms, and time. To better understand soil, let's look at these concepts through the lens of the soil series Deerwood. Deerwood is found in Minnesota, the land of 1,000 lakes. These lakes that give the state its namesake were created by glaciers. Glaciers are frozen rivers of ice. The most recent advancement of glacial ice in Minnesota spanned from around 12,000 to 10,500 years ago. The land and soil we see today were shaped by those glaciers. As a glacier moves across a landscape, it picks up material and sediment in a process known as erosion. In this way, the glacier is degrading the landscape and reshaping it. Material that has been eroded is then transported via the glacier. Eventually, this material will be deposited. At the bottom of mountains, glaciers begin to melt, and like your snowman this winter, anything that cannot melt will be left behind. The mix of rocks, stones, sand, and clay are known as glacial till. Glacial till is a type of parent material. Remember, parent material is one of the 5 soil-forming factors. Another parent material common in this area is glacial lacustrine sediment. This occurs in a lake that was created by a glacier. Soil is formed when sediment in the lake settles to the bottom. But why do we care about parent material? Well, parent material is the material from which soils form. Like children, soils are a reflection of their parents, yet they grow up to be different from them. It is not uncommon that a soil profile shows more than one parent material. This is called a lithologic discontinuity. Simply put, this is when soil forms from one parent material and is then covered by a new parent material which begins developing into soil as well. When looking at a soil, we often talk about its soil profile. We can see it is divided by horizons or sections of soil distinguishable from sections above and below it. The O horizon is our top layer. O stands for organic, which makes sense as this layer is composed of decaying plant matter, twigs, and animal tissue. Many horizons have subhorizons. These are the letters that follow a horizon and they further distinguish the section. For example, the lowercase a here stands for highly decomposed organic material, or sapric. The next horizon is the A horizon. This is what we consider topsoil. It consists of dark, fully decomposed organic matter. Notice there is no subhorizon for this layer in the Deerwood series. Several sibling series, however, do have subhorizons. Here the P indicates the horizon has at some point been plowed. The last 2 horizons have the same master horizon C and the same subhorizon G. For clarification purposes, we number the horizon following its name in a case like this. A C horizon is a layer of unconsolidated parent material. The subhorizon G stands for glade, which is an indication the layer is consistently saturated. Glade horizons are determined by their color. But if the master horizon and the subhorizonations are the same, how do we know that they are distinct horizons? Well, to separate a horizon from sections above and below it, the soil must have a change in color, structure, or texture. Soil structure refers to how beds of soil are naturally grouped together into aggregates. The 5 main types of structure are granular, platy, blocky, columnar, and prismatic. Color may be one of the easiest ways to distinguish separate horizons. Let's look at the Deerwood soil profile again. Here are the colors for each of the horizons. We can see the color for the first horizon is 10YR21. But what does that mean? There are 3 things that define a color: hue, value, and chroma. Hue is the specific color, and in this case, the YR is referring to the amount of yellow and red in the color. Value refers to the lightness and the darkness of the color. The chroma is the color's intensity. But soil isn't perfect, and sometimes a horizon shows properties of more than one horizon. These are called transitional horizons. In this case, our horizon is like B but has some of A in it. Therefore, it is called a BA. But what if the horizon is like A but has some of B in it? It's called an AB. The soil profile can also tell us more about the processes that formed the soil. There are 4 soil-forming processes: additions, losses, translocation, and transformation. Additions are when materials are added to the soil, like when we add ingredients into a dish. Losses are when soil particles or chemical compounds are eroded, leached, or harvested from the soil by the movement of wind or water or by uptake from plants, like when you remove dog hair from your food because your pets don't understand boundaries. Translocation is simply the movement of organic or mineral materials within the profile, between horizons, like when your ice cream flavors melt into one another. Lastly, transformation is the chemical weathering of sand and the formation of clay minerals, as well as the transformation of coarse organic matter into humus, similar to the transformation of veggies in a boiling pot. When we look at our Deerwood series, the most obvious evidence of one of these processes are in the sea horizons that are glayed. Glaying occurs when water moves into the soil and stays saturated, creating anaerobic conditions where the iron compounds are reduced and either removed from the soil or segregated out. We've looked at soil close up, but generalization can be helpful to scientists. This is why 12 soil orders were defined. They group soils based on distinct characteristics and their ecological significance. They are alphasols, andisols, iridosols, entisols, gelisols, histosols, inceptisols, mollisols, oxasols, spotosols, ultisols, and vertisols. So what about our Deerwood series? This series is an inceptisol. This comes from the Latin word inceptum for beginning. This is because inceptisols have minimal horizon development, thus they are just beginning to grow up. They are more developed than entisols, which we can imagine as the baby here, but still lack the features that are characteristics of other soil orders. And last but not least, please give me an A. I've already taken my grad pictures and there's no going back.